Hi friends, this is a derivation regarding linear triangular element. The triangular element I have given here. The statement is figure below shows two-dimensional triangular element in global coordinate x and y. So y, x, having three nodes 1, 2, 3. These are the three nodes. At each node there are 2 degrees of freedom in x and y displacement. There will be 2 degrees of freedom here. This one u1 v1, u2 v2, u3 v3. So this is the figure. And next, here the mapping has been done. The figure below shows master element mapped from global coordinate to natural coordinate. Natural coordinate is xi and eta. In my previous update of a problem or solution of the problem, I have mentioned xi and eta. So first coordinate, first node, second, third node. So next we'll find the shape function. We are solving equation for shape function. So the shape function, the equation is given by n1 equal to a naught plus a1 xi plus a2 eta. So this is the equation 1. At node 1, here the point xi is 1, eta is 0. So I am substituting xi is 1, eta is 0. So after substitution you'll get this equation A. And at node 2, here xi is 0, eta is 1. Xi is 0, eta is 1. So we will get this one. So next at node 3, here xi is 0, eta is 0. So a naught will be 0 after substitution. So substituting a0 value to the equation a and b, here we will substitute a0. When it is 0, then a1 will be 1. When here it is 0, then a2 will be 0. So and after gaining these values, when we substitute here, a0 is 0, a1 is also 0, because a1 is 1 xi plus a2 is 0. So eta will be 0. So this will be 0, this will be 0. So we will get only xi. So n1 is equal to xi. Similarly, for this point, at shape function at node 2, so n2, same equation, substitution. n2 will be 0 at node 1. Here the node 1, here n2 will be 0. In this point n2 is 0. So next, xi value we have mentioned there, we have to substitute that value, and eta value also same. So we will get this one. At node 2, n2 will be 1. Here this is node 2, here n2 will be 1. And after substitution we will get this. Same n3 means here it will be 0. At this point n2 will be 0, n2 is 0, xi is 0, and eta is 0. So we will get n2 as eta. And at node 3, shape function of n3, so we will get same equation, same substitutions. n3 will be 0, 1, 2, 3. So at this point n3 is 0, at this point n3 is 0, and at this point n3 is equal to 1. Okay, so after substituting the values we will get a0 as 1. So the shape function for the linear triangular element, n1 is xi, n2 is eta, n3 is 1 minus xi minus eta. And this is the variation of shape function I mentioned here. These are 3 sketches, n1, n2, n3. You have to mark it, and you have to hatch it. Thank you.